All right, so today we're going to start out by taking a look at the derivatives of inverse functions. So if you take a look at this situation here, remember from previous work that if two functions are inverses of each other, then the composite function of the two of them is just going to be x, like as is demonstrated here. Right? So let's just take the second one of that, second half of that equation there. So we have that g of f of x equals to x. Okay, so we're going to take the derivative of this. Right, so as we go through and do the derivative for this function, we can use our notation here and say that d dx of g of f of x equals to d dx of x. Okay. So as we're taking a look at this thing on the left-hand side, we see that that's going to be, we're going to use the chain rule to unpack that. So this would just be the derivative of the outer one, which would be g prime of f of x, times the derivative of the inner function, which is f of x there, okay, equals to, and then the derivative of x is just going to be 1, right? So from this I'll end up with g prime of f of x, that's a little messy there, f of x times, and the derivative of f of x is going to be f prime of x. So the idea here is I want to go ahead and find the derivative of f even if I don't know it. So in this case, as it says here, we're going to solve for f prime of x. So if I divide both sides by the left factor there, I'll end up with f prime of x is equal to 1 over g prime of f of x. Okay. So this can be handy because it allows us to actually do a little bit of work. As long as we know two functions are inverses, we don't necessarily have to have their full equations or all the information about both of them in order for us to actually answer some questions. Okay. So I'll record another video for the next problem.